Nate Lewis, who's the Caltech professor of chemistry. He's been active in the solar fuels and solar chemical field for over 40 years. He's published over 500 papers and has presented hundreds of public lectures. His current research interests include artificial photosynthesis, which we'll be hearing about today toward the end, and electronic noses, which it's not a bionic nose, as I understand it. It's a mechanical and chemical nose, and he may or may not be talking about that, but it sounds very interesting. The League has some knowledge of Nate Lewis. He gave a presentation to the Pasadena League of Women Voters 5 to 10 years ago about powering the planet. It was a very good speech then, and so today he'll be giving you an updated version of that, which is current to 2017, so we're really looking forward to hearing from him. His speech will be overview of global low-carbon energy technology and Caltech fuel from sunlight R&D. Nate?
Thanks very much for the opportunity to be here on a Saturday morning. I have two speakers that will be hard to follow, so I'll try to give you a complementary viewpoint on three topics. One, a short summary of what we really do and do not know about climate change. The second is what really did and did not happen at COP21 in Paris. And the third is what I spend with my research efforts, work trying to help us get to a clean energy system, that there are only certain things we can do, some we need to do but cannot yet do, and that's what our job is. And then I'll close with something where, a little unusual, where, because I'm normally very apolitical, but we live in a political environment. I just came back from Washington, D.C. Thursday night, and there are some things on the horizon that we could use help in the sense of we have to have people voting and paying attention. So I'll bring up some of those issues as well. On the first topic, of course, we could spend hours, but when I had the opportunity, and I really do dearly wish that we had time with Representative Chu to have her hear this. I know that our other local rep, Schiff, has heard it because I sat next to him on an airplane and had him cornered. But in case you haven't noticed, he's a little preoccupied with other things these days, which isn't necessarily the exact right way you would want this to have priorities. Here's what we know. What we know is this is a plot from ice cores, when you can see, if you drill down into the ice, a stripe in the ice for every year that the ice has melted and then reformed. There are 670,000 such years if you drill down deep enough. Every single year, we know what the carbon dioxide concentration has been, and every single year, we also know what the global temperatures have done. Now you can see that for 670,000 straight years, for as long as we have data, that when one changes, the other changes. Correlation, however, does not prove causation. But this is what we know. We also know that carbon dioxide levels over that same time period have done this in the last 50 years. They've gone from 280 parts per million, where they were stable for 10,000 years, to now over 400 parts per million, and at the same rate will be more than double what any human would have otherwise experienced within our lifetimes. You need a climate. Now, we also know unequivocally that this change is due to humans burning fossil fuels. There has been proof that, that's common sense when you drive your car and the gasoline that you burnt goes somewhere, it goes into the air, dummies, okay? We also, if that isn't convincing enough, we have isotopically labeled the carbon, and we know it comes from fossil energy, not from the oceans. And you can balance the chemical equation like burning a candle. We're consuming a little bit of the oxygen in our atmosphere, and so we know this has all come from humans. Actually, 85% of it's from humans, some of it's from other activities. What we do not know, outside of a climate model, is the extent and severity of what this will bring for our planet. We do know, when I had the luxury of giving a 10-minute version of this ad hoc to former President Clinton, that the one number that I wanted him to remember was 3,000 years. Because we know when you add carbon dioxide to the atmosphere, if we were to quit cold turkey in 40 years, how long it will last in the atmosphere of our planet. That number, an average value, is 3,000 years. Right? So what this means is, you may not believe any of those climate models. You can just look for yourself as to whether or not you think we feel lucky that although there has been a correlation for 670,000 straight years, that when we drive it off the charts, that nothing bad will happen, and that we won't be stuck with that outcome for a time scale comparable to modern human history. You don't need to know anything more than this. Right? We don't have to argue over whether or not climate change is real and happening. Why aren't we seeing more signals right now? We know that carbon dioxide is a greenhouse gas and it warms the planet. That's absolutely known from what's called the absorption spectrum of carbon dioxide. We don't know exactly by how much, because we can't predict in the models how fast ice will melt. We can't predict in the models exactly what the clouds, which act as a thermal blanket, as to what altitudes the clouds will form and how they'll redistribute. All of these variations are the variations between all of the climate models. Maybe it'll be lucky and some regions will turn out better and some will turn out worse. Maybe not. This is an experiment that we get to do exactly once, if we feel lucky. That's what you need to be telling people. Our kids and their kids and their kids have a right to live on this planet also. Right? Now we know more because I told you the time that carbon dioxide lasts in the air. I didn't tell you how long it lasts in the oceans. Anybody that's ever opened up a can of sparkling water or Perrier knows that when you add carbon dioxide to water, you make it acidic. When you add CO2 from burning fossil fuels to the air, roughly half of it doesn't stay there, but goes into the biosphere, into both the plants and into the waters of the ocean. That makes the oceans acidic. The pH of the oceans is now lower than it's been in 4 million years and probably in 20 million years. What that does is dissolve the coral which have only a narrow band of pH in which reefs can be built and survive. The carbon dioxide that's dissolved in the oceans will last for 2 million years. This is a plot of a colleague of mine, Ken Caldera from Carnegie Science, of where best scientific knowledge says historically the ocean temperatures and pHs are right to have coral reefs flourish. A few 100 million people depend on their livelihood for coral reefs. And as no matter what you think about the air, anybody that understands the simplest thing about adding CO2 to water knows that we are making the oceans acidic and dissolving the coral. And it will last for 1 million or so years in whatever state we bring it to in the next 40. Well, this is what 280 parts per million. This is the atmosphere that we got from our parents. This is where the models show coral reefs will be at 380 parts per million when we equilibrate, and we're already past that on our planet. This is where the models show coral reefs can survive at 450 parts per million. This is the map of where coral reefs can be at 550 parts per million. I went personally to the Great Barrier Reef for a beautiful experience last September. You may know that 90% of the barrier reef was bleached in the worst bleaching event on record. And I had to change my trip to go to the southernmost part of the barrier reef where the waters were cooler, because the rate, of course, depends on the temperature, and it hadn't bleached there. So if you haven't been, you should go while Nemo is still in our oceans, because the only place that our kids will see Finding Nemo is in an old movie pretty soon. So if you feel good about taking a chance, then we can just roll the dice. If you don't feel so good about that, then we have to realize that adding carbon dioxide to the atmosphere is like charging more to your credit card. It doesn't help pay off your debt, even if you stop adding it. And so cutting emissions by 80% doesn't mean you cut the effect by 80%. It just means you stopped adding more to the debt that you built up already that will last for modern human history. The only way to stabilize your debt is to stop charging on your credit card. That means you've got to go to 0 emissions. Nobody knows that this 2 degrees centigrade number is safe. That's a guess. The only thing we know is we know that the only way to keep the CO2 level stable is to not emit any more CO2. And the question is, will we be courageous enough to do the experiment of what it would be involved to keep going or not? The way I tell my public friends who say, I don't think it will be bad, and I'm not sure humans are causing it. Well, A, I'm sure humans are causing CO2 emissions. There's no doubt about that. We don't know for sure that CO2 will bring us a fundamentally different planet that's undesirable more than the benefits we have of fossil fuels. But a Ouija board is not a scientific instrument, right? And I'm not sure I'd be willing to bet that you're exactly right, given that you don't have a clue what the future will bring any more than the scientific record will. That's what you have to know about climate change. I'm going to tell you about Paris, COP21. There were 10,000 or so delegates at Paris, and they all had to agree on something. You couldn't get 10,000 such people to agree that the sun rises in the east unless they added a clause that said, except when it doesn't. It was resolved by over 190 countries that we should take actions to hold the increase in global temperature to well below 2 degrees. Now, we don't actually know what levels of carbon dioxide will produce what temperature changes. So this didn't tell us how much CO2 emissions reductions are needed. It just said it would be a good thing to hold the temperatures to below 2 degrees. It also said that sometime in the mid-21st century or later, we should not build up any more debt. We should stop charging to our CO2 credit card. It said should. It didn't say would. John Kerry actually had to intervene to get the should or into the wording as opposed to the shall, which meant would, which would have been legally binding. That's not what happened at Paris COP21. The commitments that were made, these so-called INDCs, of each country under COP21 said, well, here's what I can do for you. If you added up all of the current commitments, they would have, instead of making emissions rise, have followed this path. The hard work is, how do you get down to 0, which was not addressed in COP21 at all. Now, one other point is there was no mechanism to validate that any country would actually do any of this. They have to stand up every 5 years and make a so-called stock-taking disclosure of how well they're doing. And everybody else just has to believe them. Because there is no mechanism to monitor whether or not China or India actually did what they said they did, except that they told us they did that. There are no penalties for non-compliance, and there's no market and economic framework to stimulate people to actually do what they said they should do. Now, the good news is that you can't decide you want to build a better mousetrap unless you agree that mice are a threat. And so the very positive thing is this is the first time that all the countries of the world actually agreed that greenhouse gas emissions were something to be reckoned with, and that it would be a good idea if we did something about it. The delegates basically agreed that we should end poverty, stop smoking, and stop emitting greenhouse gases, not necessarily in that order. So this is a positive step, but you should not necessarily come away with what you read in the newspapers as if only we followed the COP21 Accords, all of our problems would be solved. There were positive things. There were things that were left on the table, all of the hard execution stuff, and the commitment to actually globally seeing our way through so we don't do this big experiment. So that's what COP21 really entailed so far. Well, now I'm going to go to the third part, because although I could give you an hour on each of those, I don't spend my personal effort worrying too much about those things, because we have our own things that we're supposed to be taking care of business on. We can do this, depending on what this is defined as. There are certainly things that are within our behavioral framework, within our ability to get economically, that can probably get us about half of the emissions reductions you would need to get to a zero emissions planet. They're well known: smarter building windows and energy efficiency in homes, plug-in hybrid and battery-powered vehicles, and all of those things that we should be stimulating in the marketplace. There are the other roughly half of the technologies that we need that are either innovations or yet to be invented. And given the long time scale that it takes for energy innovation to make it into the marketplace, if we aren't working now on those things that we need to see our way clear in the future, we won't have them ready in time for when we need them. Think about getting to the Grand Canyon and knowing you have to cross, but having built a bridge across it before you got there, and you end up stalemated. What are those things? Two of those things that are high on every list and every study. And why do we settle for 80% or 70% when we know we've got to go to 100%? Because we actually have an admission that the last 20 or 30% are within things that we have not yet invented. And we have to figure out a way to do that. When I tell them to you, you will all immediately agree and realize that we don't know how to do these things. And exactly those things are the kinds of things that researchers like myself should be doing now, so we can get better options, so that when we need them, we can pull them out of our toolkit and are not stalemated. One is, there are days, weeks, it turns out even some seasons, where every night the wind doesn't blow and the sun doesn't shine. You can't just say we're going to get a renewable energy economy and go to 100% renewable electricity without understanding that there are days at night when the sun goes out and the wind doesn't blow over the entire continent. We've done a study, Ken Caldera and myself, the first study that actually shows that. Because there are beliefs of, I believe we can do this, and California will legislate 100%, which is now being thought to float. We'll have 100% renewable electricity mandate. Hawaii actually already has one. Well, that means we had better find a technology for massive storage of electricity at grid scales. All of the batteries ever made in human history would power the United States for 7 minutes. The energy in the best battery is 1/60th of the energy in that same amount of gasoline. That's why Henry Ford ended up powering cars off of gasoline compared to batteries, because the energy density in liquid fuels is so much superior to that in batteries. There are technical reasons for that, but we don't have to get into them here, although if you want to ask me in the question and answer, I'm happy to tell them to you. Well, what did actually, even in 1931, it turns out in a conversation between Thomas Edison and Henry Ford, they realized, and this must be true because you can look it up on Wikipedia. Now, actually, you should be careful what you look up on Wikipedia, because the headline today I just saw is that Tom Brady has been traded to the Buffalo Bills for 4 years worth of draft choices in their entire team. I just saw that. It's dated April 1st, however.
This one is not that way. Sunshine is spread out thin, and so is electricity. We haven't really found out how to store it yet and let it off real easy, like in cheap. This scheme of combustion to get power makes me sick to think about it. It is so wasteful, just like a baboon. I'd put my money on this side. I hope we don't have to wait till oil and coal run out before we tackle that. That was Thomas Edison talking to Henry Ford in 1931. What happened? Nothing new under the sun. So what are we doing about it? Well, the sun has this, like I said, nasty little habit of going out every night, but nature figured out that the best way to store energy, other than the nucleus of an atom, is in chemical bonds. That's how it stored all of the energy that we now extract from our planet at a much faster rate than nature deposited it into our bank. That was with photosynthesis, that was the source of oil, gas, and coal that's fossil energy. Photosynthesis takes great idea, takes the biggest energy source known to mankind, the sun, and stores it in the most convenient, dense form of chemical bonds that you could possibly want. A+ for inspiration, D- for execution. Because if you look at the efficiency, the amount of total stored energy in all the fossil fuel and photosynthesis and all the biofuels and the fastest growing plant, and you divide all of that into the amount of sunlight energy that hit that same acre, it's less than 1% of what went in is actually stored. And then it's downhill from there to figure out how to have it net positive on a carbon balance and agriculture and trade food for fuel. So nature just did what was good enough to make plants do the wonderful things they do, but they're not optimized to be energy conversion machines. And they make a fuel we can't use, that stuff we put in the green waste, as opposed to a liquid or gaseous fuel that we do use to run humanity. So it's obvious what you'd like to do. What you'd like to do is understand that birds fly, but we don't build aircraft out of feathers. We build aircraft that they fly faster and better and cheaper for the same distance, although we're inspired by biology that we know it's possible. That's what our job is. Our job is to forget about trading food for fuel and to try to make the energy stored from the sun in a chemical fuel that can be used in order to power civilization. Now, some people say, but if you make a liquid fuel like gasoline and it came from this artificial photosynthesis, won't that add carbon dioxide to the air when you burn it? No, because it's formed from that very same carbon dioxide in the air in the first place, and it's a closed, sustainable loop. Unlike burning it from fossil fuels, where it was millions of years to deposit into the bank, and we're pulling it out in 100 years or less, and that's not the closed, sustainable loop that we must get to. Now, there are many kinds of fuels you could make from sunlight. One set is to do a variant on what nature does, carbon dioxide and water, and make gasoline. Another variant is to split water into its fundamental constituents, hydrogen and oxygen, and then either use the hydrogen in a clean vehicle arrangement with fuel cells or make fertilizer out of it, which is how all the fertilizer that feed all the billions of people on our planet is now made, and or convert that hydrogen into liquid fuel by known chemical processes. If you were to look on my website, you would see that I had the opportunity to testify in Congress in June about solar fuels. Before that, very same committee that we heard was mentioned here earlier, chaired by Lamar Smith. There were two important points to me as take-homes on that. One is that I testified that we should not be hung up on which fuel we make, because we already know how to convert one fuel into another. So if I make clean solar hydrogen, I can give you ammonia or I can give you gasoline and you'll never know the difference. So let's not direct the program to tell the scientists that we don't want to reduce CO2, or we do. Let's let us carry our water on that end and give you a fuel that's clean, that's survivable, sustainable. We'll develop that technology and then we'll let it be implemented by the marketplace. The second message is that I was called to that committee to testify by the majority Republicans. Not only that, after I testified, a bill was sponsored by the Republicans that would up the funding for solar fuels and separately for battery storage technologies. That bill made it through the House unanimously on the House floor. That bill is stalled now in the Senate, and the president's budget request has not only cut basic research for the National Institute of Health, but also for the Department of Energy, as well as for the National Science Foundation, as well as for NASA, because in budget arithmetic, if you have to find sources that are revenue neutral to up the funding for defense and for a border wall, the simple arithmetic is that the cuts have to come from other domestic programs, and this is where those cuts are proposed to be. So the help is obvious at the end of this, is that it would be a good idea if you resonated with the fact that energy and healthcare R&D should not be such a political football, that both in the continuing resolution, where it's just came out that there are marks to cut those very same things right now to get a head start on what would happen later, that we let people know that that's probably not a good idea. The second point is that people say, if the federal government doesn't do this, we're going to do it anyway. Well, actually, I would love to take Governor Brown up on those words. I would love to take Governor Brown up on California's going to do it anyway. Well, if we're going to meet our clean energy goals and even exceed them and get this system to carbon neutrality by 2050, there are certain things that we'd better invent. And so we've got to have some capability to harness all of the intellectual horsepower of the small businesses, of the national labs, and of the research universities in California. And if the feds aren't going to do it, we better start getting them to work to do it ourselves. We've got the horsepower, but we have to turn them on. All right, so let's have him actually do what he said. Now, what do? Our job is to try to do what nature did, but better. 10 times better. Now, actually, we know this is possible. This is a rock. It's a mineral. It's called strontium titanate. So we knew 40 years ago it was possible to beat nature at its own game. And instead of making electricity that even Edison knew couldn't be stored, to develop a totally different technology than solar panels, and a totally different technology than biofuels that would give us new options, that would take sunlight and store that energy in chemical fuel so we could burn it later or put it in a fuel cell in a totally clean way, that would help us get from that 80% to that 100%, or maybe even from the 50% to the 100%. Because it would solve the grid storage problem and solve the transportation problem, because there ain't no such thing as a plug-in hybrid airplane. right? Right? Nature does this by giving us a blueprint. There are two photosystems. If you remember your high school biology, if not, all you need to remember is Dr. Seuss, thing 1 and thing 2. There's photosystem 1 and photosystem 2. And just like thing 1 and thing 2, these are both chlorophylls. Now they're green to the human eye, and the reason is because you need a certain amount of energy to split water, to make and break chemical bonds. And if you do that with one absorbing color, you end up with it being in the blue part of the rainbow. It has to be very high energy. But there's not much sunlight in there, and you're wasting all the other colors. So it's much better to have two of them and hook them up like two batteries, like in my laser pointer, in series, to have them step up the voltage and add it together. And each one then can use a lower energy part of the rainbow in the red. That's why plants look green. It's the complement. And they take two red photons of sunlight and then make the energy equivalent of one higher energy one. So that's one thing. The next thing is they need catalysts. That's what biology does with enzymes. It's got to catalyze not electricity flowing through wires, but making and breaking chemical bonds. There are two key catalysts. One is the manganese catalyst that is the source of all oxygen in our atmosphere. That's all photosynthetically derived. We wouldn't be in an oxidizing atmosphere without it, and that's nature's catalyst. But it doesn't survive very long. Plants rebuild themselves every 30 minutes and waste a lot of energy doing that just to stay alive, because otherwise they would have radical damage. They can't have sunscreen because then they don't have sunlight in order to grow and live. And they get radical damage, just like humans do, that then they spend a lot of their energy budget that they made just rebuilding so they can make more energy. At universities, we call this overhead, right? Nevertheless, we want to minimize that. And then there's another catalyst. It makes the sugars, NAD and NADH and glucose, and that makes all the good stuff, all the energy-rich fuels. And then there's a membrane to hold them all apart, because if we made these fuels together with the oxidizer, they would just explode. So nature figured out the blueprint. So this was our blueprint. We want to do it better. Just don't want to copy it. Why would we want two of those thing 1 and thing 2 pigments to both be the same color? That's not a good design. We want one to look red so it absorbs the blue part of the rainbow and let through the other stuff. And then we want the other one to look green so it absorbs all the red parts of the rainbow. And then you can equally balance the intensity in the blue with the intensity in the red and get just as much matching to give you the maximum energy. This is obvious. I inadvertently put this up when I testified on Capitol Hill, and immediately Chairman Smith interrupted me and said, "So are you saying that because this is red and this is blue, that this needs to be something that is bipartisan?" And of course, as a scientist, I had never gotten that perspective on my work. But I was happy to say that this was a clear opportunity that should not be political, because it would involve both energy security and environmental security at the same time. And this did pass the House and committee unanimously, actually. Well, we want them to be rods with these colors. Why do we want rods? Because let's think about what nature does. It doesn't have like a solar panel out in asphalt. It has blades of grass. It has aspen trees. There's a very long axis to absorb all the light and then move those things sideways a short distance to get the nutrients into the growing tree. That's a good design. That's what we do. We want to build these growing trees or blades of grass out of nanofibers, of materials, the same materials that are used in solar cells to make electricity, But we want one set to be blue and one set to be green, so they match our rainbow, and we need to invent catalysts that make fuel, just like biology did, with a membrane that separates our products so the thing doesn't explode and go boom. Well, this diagram, this identical diagram, was something that we conceived in my research group at a group off-site retreat about nearly 10 years ago to the day. It's still inspired researchers around the world because nobody has beat this design of a better way to think about beating nature at its own game. Now, in my research program at Caltech, we have been funded generously by the National Science Foundation, by the Department of Energy, and now by the Gordon and Betty Moore Foundation, as we pursue the goals of trying to build this thing. If you look very recently, and I couldn't play it because we don't have an internet connection here, you can even see that I had a visit on my birthday from my friend Bill Gates, who has pointed out how important, we made the front page of his blog, there's a whole video about our research, and about how important government R&D is, because this is too risky for private industry to adopt, because we can't make money off of something that hasn't even been invented in the next 3 years. But if we're not doing things like this, we won't have that bridge built over that Grand Canyon when we get there, and we can't afford to not do these things now so that we have them ready in time. Now, if I wanted to, I could take another wonderful hour and tell you all the progress we've made. When we started this, we had none of these materials. We had none of these catalysts. We had none of these light absorbers. We didn't have the membrane. We didn't even know if the idea would check out based on modeling. We've checked out the idea. We have 4 out of these 5 materials by now and a workaround on the 5th. We've shown it's possible to make fuel from the sun in the lab at 10 times more efficiently than the fastest growing plant, in a way that you could think about could be rolled out and scaled up. Yeah, I'm skipping all that stuff. That would look like a carpet, or a high-performance rain jacket, or I like to call bubble wrap that goes on my pool cover. Except you would roll it out, and in would come sunlight, and out comes stored energy and chemical fuel in a set of lateral drainage pipes. And then you can burn it. You can use it for power your cars or your homes. Except that what we have is only as big as a thumbnail and only lasts now for a few hundred hours. So our job is to do the invention, because when we get the plane off the ground, humans have been shown to be good at innovation, to making things faster, better, cheaper, provided that we want to do that. So in the end, it is people like this that we need to be betting on, right? It is these graduate students and postdocs who are eager, who are international, who come from all over the world to do this research at places like Caltech in your backyard to try to give us better energy options for the future than the ones we have now. I told Congress, they said, well, why should we do this? I said, because I'm asking you to bet on America. I'm asking you to bet that we will continue to innovate, and that if you give us the resources to do that, that I feel confident that our kids are going to come through, right? And my job is just to keep them on course and have fun as we do it, We do a lot of really interesting science and a lot of exciting things, and this is spreading around the world. There are international efforts that we partner with in China and India, in Europe, that all are coming just right down the road to see how we're doing what we're doing and what we're doing, and we shouldn't cut off our legs as we're just rounding the first turn of the race when we're ahead. So with that, yes, there is that energy bill that passed the House. It's called H.R. 589. I'm one of many people who have written letters to the Senate, to both parties, both the chair and ranking members, saying that that would be a good thing to keep your eyes on the ball in this bipartisan environment on maybe one of the few things left that we have that is not polarized, and to actually pass, which they've all agreed in committee to do, but it's not quite on the Senate's timeline now for reasons you might understand. And it would foster research like this, as well as in general, we've got to keep our eye on the ball with respect to the R&D at NIH, at NSF, at DOE. And when I got this passed, I never had to mention the words climate change or emissions. It makes sense for lots of reasons. It makes sense for energy security. It makes sense for environmental security. It makes sense for options in the future. And it makes sense for us to just bet on our generation of scientists that they'll pull it out when we need them. So with that, I'm happy to answer questions, and I hope this has been helpful.
We can use solar panels to split water.
We can.
And hydrogen to make fuels. How do you see the interaction of those two technologies?
Right. Okay. So what he's referring to is that we do have existing technology that can take solar electricity from solar panels and then hook it into units called electrolyzers and convert electricity into fuel. The problem with that right now is that it costs too much money to make hydrogen fuel that way. Best estimates are that it would be the equivalent of $12 or $15 a gallon of gasoline at the factory gate of the hydrogen made that way, even as the cost of solar panels have come down tremendously. The reason is that the electrolyzers are only used 20% of the time, because on average the sun day and night and during the day doesn't make 100% of its rated power, but only 20%. And so you've got this capital expenditure that you're not fully utilizing. You could do better if you had these electrolyzers hooked up to the grid and had them grid connected to use both solar and wind together. It's still an expensive option that could, in principle, be made cheaper. You still have to face the same challenges we have, which is some of those catalysts are just the most scarce elements on Earth, platinum and iridium. Iridium is found in meteorites and in South Africa. Maybe a good new exploration mission for NASA is to go get iridium off of meteorites to support these things on Earth. But I shouldn't say that because somebody will probably think it's a good idea. So it's cost and scalability.
Question, so these and then if so, is there a possibility if we have enough energy, we can just use that, take the
Oh,
carbon
good.
dioxide out of the air and stick it back in the ground?
Perfect. Okay. So there were two questions there. One is that if you're splitting water to make hydrogen, then there's no carbon involved at all. When you burn it, you just make water again. So that's a totally carbon-free, not even carbon-neutral cycle. The second part of that is if I use that hydrogen to efficiently fix the carbon dioxide, then in principle, although there will always be losses, the losses could be small. So it would be like 90% carbon neutral that way. The third part of your question is to what's known as carbon capture and storage, but not in this case from fossil energy, which could at best lead to avoiding of emissions, but bioenergy, for instance, taking plants and burying them, or burying their carbon dioxide that's burnt, actually pulls down emissions from the air, leads to so-called negative emissions. Now, the problem with this is, A, you have to figure out a way to put it all somewhere. It's a lot of CO2, the equivalent of Lake Superior every year underground. It can't leak anywhere for 1,000 years, or you emit it back again. There are other technical things. The Intergovernmental Panel on Climate Change, however, has in all of their scenarios unrealistically large amounts of exactly that phantom technology, because it's kind of the joker in the deck that makes the arithmetic work out. If you don't think you can cut emissions fast enough and you've got your budget built up, then you can always bail yourself out mathematically by pulling out of the air what you put in there in the first place with these so-called negative emissions technologies. Most people think the amount of negative emissions technologies they put into these pathways is unphysically large just to make the arithmetic work out, because they're trying to have hope beyond hope that we won't delay emissions and have to go to this thing. So it's dangerous to put all of your cards into hoping that negative emissions technologies will work out because we didn't do the job in the first place, which would be by far the preferable way to go.
Brief question, because you scientists are proving Sherwood and Rowland from the 70s and 80s true.
It's Roland and Molina, but they were ozone, so situation is similar.
We face a planetary emergency right now because we're witnessing changes in our lifetimes that we haven't seen in years. What do we need to do right now?
So, okay. This is my personal assessment of the situation. First, I think that this is like the war on smoking. What did we and didn't we get? And the lessons learned from the war on smoking. Now, George Shultz, our former Secretary of State, actually agrees with me here. I've had this conversation with him, and he's a Republican. But agrees, this is like the war on smoking, where we don't have one silver bullet. I shouldn't be telling you, bet the world on this, because there are so many things that we need to do and get aligned that are small steps. We didn't have technology of e-cigs come out that reduce smoking and deaths by that. We didn't depend on one legislative thing. We had a whole series of coordinated actions over a 30-year period, from the movies and magazines and then in bars, and each of which accounted its own resistance. But there was this force that kept aligning things toward the end goal from various political and legislative and social mores and technology. And that's what you need to do to be successful here. We shouldn't be saying it's all just about legislating the next law, it's all just about this. It's got to be the vision that the path of success has many stepping stones, but we don't have the time to go down dead ends. And so we shouldn't be doing things that aren't aligned with getting to the end of this maze by the time we have to get there in the one shot we've got. So we've got to keep everything aligned. Now, there are two broad things that I think this comes down to. One is that individual actions that we heard the last speaker talk about. And we can go a long way with individual actions, but we can't get the whole thing done that way, because there are some things that we just have to invent, and some things we just have to get the cost way down, that if clean energy were the cheapest energy, we wouldn't need any legislation. Everybody would just buy it for sure. Every PUC would just invest in it. So we've got to get on the ball with the technology also to help lead the whole nations of the world in making clean energy the cheapest energy, so it's a no-brainer that we adopt it. And those things, we've got to make energy R&D and energy policy a voting issue and an issue at PUCs, even the Pasadena ones, the local ones. Most people don't pay any attention to what happens at those things, but they regulate how much clean energy we're going to buy. The CEC, this is half political as much as it's half individual. And I think we have to decide that this either really matters or not. And if it really matters, if it matters as much as healthcare, if it matters as much as these other things, we have to bring it to the forefront here and now, just like those other things, because that's the way through.
Apropos of your comment about your international laboratory group, I read, I think yesterday in Science Magazine, that in the latest Intel Science Fair, they had 40 finalists at the high school level. 83% of them had either one or both parents immigrants. That was pretty striking, and certainly reinforces your comment about the importance of keeping our borders open for this. The question, I believe it's the case that you're not the only Caltech professor involved in energy research.
That's right.
And I wonder whether you could share with us maybe one or two highlights of what some of your colleagues are doing that you think might be particularly interesting.
Well, we only have 1 minute left, and I would have to take an hour to give that justice. There are colleagues of mine working on smart grid. There are colleagues working on fuel cells. I have colleagues working on climate change monitoring, on satellites to monitor CO2 concentrations around the globe. I have colleagues working on space-based solar power, that you might beam down solar panels, and other ways of making them cheaper. And so those things are both radical inventions and innovations along our existing path. My personal interests are much more in the radical innovation, because I personally feel that that's where I can have the potentially biggest impact. We would have lots of other mechanisms to lower the cost of solar panels, but if we don't have the inventions of how we're going to make our fuel, then we're not going to have that bridge built. So that's why I vote with my feet.
Take one more and that's it.
I'm wondering if it is timely for all of us to write to our senators plus the chair of the Senate Committee on Energy and Natural Resources about this bill.
Well, I put it up there for a reason, and you have the addresses, and you know what the bill's name is, so I don't think it would be a bad idea. Right. But I think in the broader picture, this was happening a month or two ago. In the bigger picture, what's happening now with the so-called skinny budget from the president, and then the continuing resolution that have these very significant cuts in energy R&D. So how could we get this through if we're cutting the base budget by 20% starting next month, and the NIH and the National Science Foundation and NASA having these broad cuts are cutting the legs out from under our country. And so I think that the broad impact, which is the flavor and concern of the month, should also not escape your attention. Great.
Thank you very much, Nate Lewis.